available on our ASCE section website later. And just a forewarning and housekeeping stuff right now, if you guys have any questions, please use the Q&A function at the bottom of the screen to type in any questions, and we'll address those at the end. Can I take it from there, Joe?
Well, I'm gonna try. I don't have control now. There we go. It's working now.
Looks like it on my end.
Yep, I think we're live.
There we go. Okay, everyone. We're going to work through this. We're, of course, not on Zoom, so it's a little different technology for us. And I'm an old guy, so technology is difficult. So I apologize for any slip-ups that may happen today, but we'll try to get through it the best we can, or at least I will. We want to thank Janet Fleming for hosting today's virtual event. This is the Phoenix board as it is right now. And anytime you have any questions or want more information, you can contact any board member. There's more of our chairs of our committees. We're going to start voting for the new board. I believe it's either going to be this week or next week. And again, you can contact any board member to see how you can get involved. Obviously, the more people we can get involved, the better it is for everyone. So if you have any notions of getting involved, please contact us. We would love to have you join us. In July, we're not going to have an event. We are trying to host a little get-together, but National has decided that we should hold off on any in-person meetings till at least September. So we're going to follow their guidelines here. In August 26th, we're going to have a sustainability workshop presentation and engineering for a sustainable future. We hope you can join us for that event. It should be very, very interesting. Mike Neighbor puts that together and always does a fantastic job. And Mike has started a sustainability committee. And if you want to get involved in that, please contact Mike. On November 8th, 2021, we're going to have, as far as we know right now, an in-person state conference. ASCE and ASHE getting together, and we're really looking forward to that. Might be the first time in a long time all of us can actually look at each other's faces. So keep that date in mind. We're still working on a ASCE member, get a member, and we're competing against other branches and other sections. So we would really like it if you can talk some of your coworkers or fellow engineers into joining ASCE if they're not already a member. And again, we're always looking for sponsors for ASCE for our Phoenix branch. We have some sponsor levels there. If anyone knows that their company might be interested or knows of anyone who wants to be a sponsor, we really would appreciate it. We're going to issue PDHs for today's program. This one was from the last program we have, the Cool Pavement Pilot Program, but obviously the new PDH will talk about our project today. And with that, I'm going to introduce our presenters. And Jimmy, I hope I get your name right. Jimmy Noukaitis, John Lang, and Lise Green. And Jimmy Noukaitis works for the Arizona Department of Transportation as a senior resident engineer in the Central District. A second-generation Phoenician, Jimmy graduated from Arizona State in 2011 and worked briefly in the private sector before moving to ADOT in 2013, where he began his ADOT career in the Engineer in Training program. Since completing the program in early 2015, Jimmy has worked in the Central District on a number of construction projects for both the state and various local agencies at multiple field offices around the Phoenix area, and currently at the Black Canyon Field Office in Central Phoenix, where he has been since late 2017. Jimmy spends his free time volunteering in his church's media department and spending time with family and friends. Don Lang is a senior engineer for Stanley Consultants here in Phoenix, where he has worked for over 20 years. He was the lead structural engineer on this project from the pre-design phase through construction. He received his degree in civil engineering from the University of Arizona and is a registered professional engineer in Arizona, Nevada, Idaho, and Utah. John's bridge design experience includes structural steel, cast-in-place post-tension concrete, precast, pre-stressed concrete girder, and conventional reinforced cast-in-place concrete bridges. When he can get away from his home office, he enjoys spending time with family, do-it-yourself home improvement projects, and playing with his 2 Labrador retrievers. Reese Green serves as a regional structural manager for Pole Ice Construction with over 15 years of industry experience and over 20 years of direct management experience gained since his time in the U.S. Marine Corps. Reese was fortunate enough to serve abroad and participated in the tip of the spear operations in Afghanistan, which included OEF's first amphibious assault into the landlocked country of Afghanistan. At the completion of his service, Reese then pursued and completed an engineering degree from New Mexico State University. He has since participated on a variety of complex, highly visible, heavy civil projects throughout the Southwest. He is an active member of AGC and also chairs a local nonprofit in Phoenix called the Ripple Effect, whose mission is to support other veterans as they reintegrate back into society. Reese's personal board of directors includes his wife, Felicia, daughter, Cecilia, and Evelyn, and son, Elias. So with that, I'm going to turn it over to them, and they can provide us with this wonderful presentation. Jimmy, I believe you should have screen sharing.
All righty. All right. Everyone see that?
Yep.
All righty. Now I got expectations that it's going to be a good presentation, like Joe said. Okay, well, at least for my part, I'll give it a shot. John and Reese won't have an issue. So, yes, like we said, this presentation is about the I-17 and Central Avenue Bridge Replacement Project, and we're subtitling it Construction in the Year of COVID. So we'll explain that a little bit as we get further on into the presentation. Kind of brief introduction. We already had our intros. So myself, Jimmy Noakaitis, I'm senior resident engineer over here at the Black Canyon Field Office for ADOT. John Lang, he was the primary bridge designer for Stanley Consultants, and then Reese Green is the senior project manager for police construction on this project. And you'll be hearing from them later in the presentation. All right, so I'm just going to provide a brief, quick overview because I know you guys don't like owners droning on and on and on and on about their projects or whatever. And also John and Reese's stuff is far more interesting than what I've got to talk about. So real quick, the 3 Ps for this project, I suppose, something I came up with late at night. The purpose of this project is to replace this structure here, the existing I-17 and Central Avenue overpass, which was about 63 years old. So it's to replace that with a new, quote unquote, state-of-the-art bridge to not only facilitate traffic on I-17, but also to account for the future light rail expansion in the area. The process is a phased bridge construction where we would demo and rebuild the bridge one half at a time. Because I didn't realize this, but apparently you can't shut down a major interstate freeway in a major metropolitan area for 8 months. But they told me that was not a good move to make. So I was like, okay, all right, I'll let you guys make the decision. Turned out very well. So glad they didn't have me consulting in that end at the beginning. And the product is, as you will see, a modern 3-span steel bridge over Central Avenue, allowing for maximized clearance underneath for both light rail and heavy truck traffic, as well as providing a conduit of traffic over Central Avenue for I-17. So I'm just going to kind of show some of the existing conditions. One of the, I guess, big things that we wanted to get away from, and why one of the big reasons why we replaced this bridge is, as you can see, the 13-foot 11-inch clearance. This is one of the lowest clearance bridges, I believe, on the ADOT system. A lot of the bridges along this corridor are fairly low clearance. I think 16th Street's about 14 feet. Either way, this was one of the lower ones, so we wanted to make sure, as you can see, the large truck traffic in the area, very low clearance. We had a bridge rehab project probably about 3 or 4 years ago to straighten out some of the girders in that area that had been hit, so it was an ongoing issue. You can see some more existing conditions. It was a single span bridge. John will get into that a little bit further in the presentation as to why this existing bridge, was a single span, and why our current bridge has a single span across Central Avenue, but in the 3-span matter. I'll let him get into the nitty gritty on that. And again, this is showing a little bit at the start of the construction, some of the initial phasing work that we were doing in the median. But as you can see, again, small footprint area, single span, low clearance on the bridge. So that was one of the biggest reasons why we wanted to replace this bridge at this location. Just really quick, for the project, the programmed amount was $20,440,000. Contract time was 565 days, and the contract was awarded to police in I believe it was March of last year, and construction started early in April of last year as well. All right, so that's the project development. So I will hand this off to, oh, here we go, stop sharing. Pardon me, I'm not too familiar with WebEx, but now I will attempt to pass this off to Mr. John Lang, and he will continue with the design side of this project. It's a great thing. This whole thing is going to be captured on video, so I can see years from now how terrible my presenting skills were. But hopefully all my jokes landed. I can't hear any of you laughing, but I'm imagining that you were all laughing hysterically.
They were great. Let me see if I can get this going here. All right. Can you see my screen here?
Yep, great picture.
All right. Like Jimmy said, I was the lead structural engineer for Stanley Consultants on this project. The excuse me. The just one second. Let me see if I can get this. Okay, there we go. So we, like Jimmy said, we had an existing single span bridge. This is a rendering of what the final product is to look like. When we started the project in the phase 1, the DCR, it was based on the Maricopa Association of Governments I-10, I-17 corridor master plan, or spine study. I kind of refer to that as the wish list for I-17. It's the ultimate build out. But close to the end of the DCR phase, the project was reduced to the auxiliary lane concept, and instead of the ultimate configuration, we're adding auxiliary lanes to each side of I-17, and to account for the future widening. Some of the project goals for this project was to replace the existing aging I-17 Central Bridge, The bridge was fairly old, reaching the end of its lifespan. It had gone through a number of repairs and upgrades. We needed to increase the vertical clearance, like Jimmy said. Valley Metro was planning to extend their south central light rail through this area soon. So that's why this project was moved up a little bit. We needed to minimize the structure's depths. Like Jimmy said, the existing bridge was a single span, and that resulted in a fairly deep structure depth. So we needed to come up with a bridge concept that minimized that structure depth. And we had a goal of improving the turning movements and the sight distance for traffic along Central Avenue. This is just a graphic showing the extension for the Valley Metro Light Rail South Central extension. You can see this is our project location, and they are hoping to have their rail done through there by 2024. The existing overpass, like Jimmy mentioned before, was about 60 years old, built in the early 1960s. It was originally independent northbound and southbound bridges, and the median infill was completed, I believe, around the end of the 80s. It's a single span steel plate girder bridge, approximately 122 feet long by 113 feet wide. It has full height retaining abutments, which proved to be a little bit challenging, especially for police and constructing the new bridge. The abutments were on spread footings. Like I said, the superstructure is about 6 feet deep, and the vertical clearance, again, that's a kind of a key issue here, was 13 feet 11. Here's a couple photos of the existing underside of the bridge. You can see in this photo here, these are post-tensioning rods that were actually added to the bridge shortly after it was constructed to help improve its live load capacity. This is the center or middle girder that was added for the median infill project. I don't know how well it shows up, but you can see it's slightly deeper here. It's got kind of a taper to it. And all these little birdies here to remind me to point out the fact that if you've ever driven under I-17, you know there's a pigeon problem, and you can see some of the bird netting that's installed there, and that will be replaced on the new bridge. And did we mention vertical clearance? I got a call or an email from Jimmy, I think it was middle of February, that the bridge had been hit, and first thing that went through my mind was that it was the new bridge, but fortunately it was the old bridge, and the timing really couldn't have been better. This trailer hit the exterior girder and closed traffic there for a while, but fortunately the bridge was going to be removed within a couple of weeks, so it couldn't have come at a better time. Some of the challenges that the design went through was there are a number of existing utilities running down the center of Central Avenue, and that really affected the bridge type that we could replace the structure with. We had to maintain traffic on I-17 and Central Avenue at all times, other than short duration closures throughout the construction project. We had to use phased construction in order to remove a portion of the bridge and then construct it, then remove the other half and construct it. So phased construction was essential here. We needed to minimize any profile changes on I-17 because raising that profile just extended the project limits and made crossing over traffic much more difficult. We also needed to minimize impacts and no profile changes to Central Avenue. And it's not really a challenge, but it was somewhat of an anomaly when we were designing the the piers, there was one boring location that indicated some pretty soft soils. Like I mentioned, there's a number of utilities within the Central Avenue roadway, and so we wanted to avoid doing anything within Central Avenue. One of the biggest surprises that I had during the project was this ADOT storm drain tunnel that runs down the middle of Central Avenue. Apparently, there's 3 of them within Phoenix that were constructed during the completion of the I-10 through Central Phoenix. This is a couple photos of the storm drain tunnel. You can see that they used a tunnel boring machine, and the out-to-out diameter of the tunnels were about 23 feet. So we didn't want to do anything within Central Avenue and wind up causing any impacts or damage to that. This is known as a helicoil down drain, and apparently they are used to slow the velocity and amount of debris of the storm water flowing into the tunnels. And the tunnels collect storm water from about 44 square miles of downtown Phoenix and discharge it down to the Salt River. Jimmy mentioned phasing is important on this project. This gives an example. We had to maintain 2 lanes of travel for I-17 in each direction. Phase 1, we shifted traffic all the way to the northernmost portion of the existing bridge, so we could, or Reese could, demolish and construct the southern portion. And then for phase 2, we shifted traffic to the new phase, or the new constructed portion of the new bridge, so we, or Reese, could demolish the remaining portion of the existing bridge and construct the northern half. This is just a slide from our DCR that shows the number of alternatives we looked at, and this isn't even all of them. I think there was a total of 11 or 12, but after everything, we came down to a continuous steel plate girder bridge that seemed to meet all of the criteria that we needed to for the project. Here's a few concept sketches of different bridges that we were looking at. The first 2 is a 2-span precast pre-stressed concrete girder and a 3-span precast pre-stressed concrete girder were really the direction that we had started down, because they met the criteria of minimizing impacts to I-17. However, the problem here was one of our goals was to stay out of Central Avenue and improve turning movements. So constructing foundations within Central Avenue was not a good idea. And through numerous meetings with Valley Metro, they didn't really like the idea of having substructure or columns to deal with and have run their trains between and around. So this is the configuration that we came up with. The substructure elements are held outside of the Central Avenue cross section, and we minimize our structure depth to minimize any impacts to I-17, and we stay out of Central Avenue, so we don't need any excavations. We'll leave that up to light rail. This is the bridge layout that we finalized. We have a 256 feet long bridge, 3 spans, 64, 128, and 64. The center drop-in span between the field splices here is about 80 feet. Some of the goals, like we mentioned, was phase construction, staying out of Central Avenue. So the plate girder bridge, or the steel girder bridge, was advantageous because it could be constructed in pieces. In theory, you could erect span 1 and span 2 girders. without affecting traffic in the middle, and then come back and drop this section in. I don't think that worked out exactly that way, but that was the thought. By having a continuous girder, as opposed to if we were using concrete girders, the concrete precast concrete is able to span the distance fine, but they're not continuous. We can't count on the back spans to help alleviate the loads in the center span. So consequently, the structure depth gets deeper. Here we can count on the end spans because of the continuity over the pier, and the steel allows us to kind of vary the shape of the girder to help reduce the structure depth over Central Avenue and give us the vertical clearance that we needed. The when the bridge is done, we should have about 16 feet of vertical clearance, and then when the light rail project comes through, they will lower Central Avenue a foot or a little bit more to provide the 17-foot plus vertical clearance they need for their catenary and electrical. One of the things was in Phoenix and in Arizona in general, steel bridges are really uncommon, and I was really surprised when all was said and done that we actually wound up designing a steel bridge. But in our case, it has definite advantages. Like I mentioned before, the continuous girder helps us reduce the structure depth. It provided for phase construction. It you know, the lighter girders equated to smaller cranes. You assemble them in pieces, so you can have the smaller sections for shipping and for erection. So the steel girder really worked out well for this project. One of the things that I was mentioning earlier about the phase construction, as an engineer, we know that it has to be done. We put a line on a piece of paper and we say temporary shoring here, which is pretty easy. Reese and police are the ones that had to design the temporary shoring and account for it. You can see that due to the layout of the new bridge here, this span is empty underneath, but the existing bridge has full height retaining abutments. So all of this dirt behind the existing bridge needs to be supported while this bridge is being constructed. So this is a photo of the soil nail wall that police constructed behind or between the phase 1 and phase 2. This is the backside of abutment 2. So they did a really good job on that. It's one of the real challenges, I think, with this project. This photo kind of goes with the previous photo. This is Pier 2, adjacent to that soil nail wall and the remains of the existing abutment. You can see there's only about 2 feet difference here, so they're pretty tight conditions. That resulted in extensive use of mechanical couplers because of the tight narrow distances here. We couldn't develop our reinforcing lap lengths between phase 1 and phase 2 or up in the deck. So wherever we had a construction joint, we had mechanical couplers. So when they're contractors ready to build the next phase, they'll come in and thread in the bars and provide us with the necessary lap lengths. I mentioned an anomaly with the substructure. This is just a screenshot from one of our bridge models. Brian Davis designed our piers, and there was something really strange with this one pile, or this drilled shaft at the south end of Pier 1. All of the other drilled shafts within the piers were able to be about 46 feet, I believe, but this one had to be a little bit deeper. And Brian and Keith Dolan at Ethos did a lot of working together and investigating and talking with ADOT. And what I think they found out was that the boring that they did for the bridge was close to one of the borings that was done for the storm drain tunnel. So the backfill and whatnot kind of affected the boring and gave us lower capacities, which resulted in that shaft needing to be deeper. The bridge has, we went through a lot of aesthetics. The you can see these are some pictures of the aesthetics during construction. I didn't really have anything other than renderings showing the colors, but I'm pretty sure that the color of the girders and the rustication aesthetic pattern is similar to the SR-143. I think Joe Salazar named this Hohokam Pottery Red, something like that. So, but that's what the steel girder will be painted. I try not to stick a bunch of information into slides, but bear with me on this one. This is just a bunch of the bridge information. So we bridge is 256 feet long, 134 foot 10 wide. So we have about 34,500 square feet. There are 16 girder lines, erected 7 in phase 1, 9 in phase 2. Total of 48 girder pieces with 32 field splices, which equates to lots and lots of bolts. I remember talking to one of the guys out there when I was made a site visit, and they just kind of shook their heads at all the bolts. Girders are spaced about 8'6". The structure depth varies from 4 foot to 3'7", minimizing the structure depth over Central Avenue. We have stub abutments with 8 drilled shafts, each 48 inches in diameter, 40 feet long. And each pier has 6 foot or 6 columns, and like I said, they're supported on 60-inch drilled shafts, except for that first column. And for this project, we used MSE walls. They're about 220 feet long each, for about 8,600 square feet. And this is just a short video fly through that we did during the, or Nick Dorsey did. He's really a genius at this stuff. So we're traveling north on Central Avenue. This is before the construction of light rail. You can kind of see some of the aesthetic patterns and stuff. But kind of gives you an idea of what the bridge looked like afterwards. And then this is just an acknowledgement of all the people at Stanley that worked on the project, and our sub-consultants, Ethos for geotechnical and Aztec for maintenance of traffic, aesthetics, and utilities. And now let me figure out how to turn that over to Reese here.
All right. I think
Got it?
there. Yeah. Let me get this. Okay, I think we're live, right? You guys see that?
Not yet.
Right. Yeah.
There we go.
Okay. Is it in present mode?
Not
Well,
yet.
if you start the
Start the
slideshow, it should, yeah.
That's the presenter view, Reese, I
Okay.
think.
In share mode. I can't see it whenever I present. So give me a little feedback. You seeing the full view or not the full view?
Oh, we're not seeing the full view. It says you're on slide 10.
How about that?
That's good.
Okay. So yeah, Reese Green, project manager, police construction. Like John said, and Jimmy said, it was phased construction, and really right out the gate, we were awarded February, March. Construction started in April. And with it being phased construction, our first order of business was to establish a median work zone so we could move forward with median removals. If you recall, the majority of I-17 has like 32-inch roadway barrier with expanded mesh glare screen, which is it's old, so it's in bad shape. So we established the median work zone. You can see our removal crews and our temporary paving crews in the median with our work zone established. That allowed us to cross traffic over and put traffic in that existing northbound, and we stacked them 2 and 2 in both directions with a piece of barrier running down the middle to delineate traffic. Once we established our work zone and got traffic switched over, we started simultaneously working two aspects of it. He smartly pointed out we had to shore the existing traffic that we had moved over to one side in order to remove the bridge as the bridge got longer and wider. So we got the majority of the shoring soil nail wall lifts in prior to the deck removal, but we had to find a stopping point because once you peel the concrete deck off and you sort the rebar, you have to be able to hoist your structural members, your steel members up on the bridge to get them out of the way. There just wasn't enough laydown downstairs because of the amount of traffic that crosses Central Ave. So over the course of a weekend, we played the road, we closed down the intersection, we knocked off the concrete deck, we sorted the bar, we cut all the intermediate diaphragms with some heavy duty shears, and we hoisted up the existing steel members up on top of the abutment. We did this because we had to abate these girders to find a cut point to be able to put them on a 40-foot float and haul those to the recycler. So like I said, there just wasn't enough room on the bottom. So this was the phasing inside of the phase construction. You can see up in the top left of that picture, you can see the first two nails on that west side abutment. You can see part of the abutment being removed, and it was imperative and required to get that shoring in prior to taking down the existing abutment and extending that excavation. But we still had to keep it high enough for a piece of equipment to grab in tandem and hoist that structural steel member up on the abutment for abatement and to cut it and transport it off the job. The demo was over the course of a marathon weekend, as is most of our work that requires full closures. Here's another view of the nails. The design ended up being about a 21-foot nail. They were spaced 4 and 4 up and down. We had 4 lifts for that installation. You can see there's about a 2-foot shy distance between our barrier that we have up there protecting traffic from our work zone. Our procurement team, our estimating team smartly cast a bigger net for drill shaft foundations. And we know from experience working in SGC that there's 2 ways. One's temporarily casing the hole, or the alternative is an open flatted auger with a polymer slurry. And the issue with the polymer slurry is there's a train of equipment that comes along with batching the polymer and then advancing the case on, keeping that hole full of drilling fluid to keep it from caving. And there just wasn't a lot of real estate down on Central Ave. And we were fortunate enough to partner with the city of Phoenix and ADOT and grab an extra lane down in the bottom, which just helped us with lay down, with drill shaft cages and what have you. But as far as the construction, the abutments were developed in the abutment cap, so there was no transition cap like at the piers. But to limit the amount of equipment that would be required to install these foundations. We're able to do it with the casing rig. So there was some casing laid down, but we didn't need 4 or 5 Baker tanks out there with polymer slurry and a settling tank and a fresh water tank. So that really helped with ingress egress to the site, especially on Central, which is very crowded. So here's a good example, and this is the phase 2 installation of the abutment drill shafts that were provided by Blunt Contracting. You can see the abutment 2 on southbound. This was about a month and a half ago. You can see taps on there. We have our form work up. We're waiting for reinforcing steel on abutment 2, ready for iron. Here we're hanging steel, like John said. The configuration allowed us to hang at least a span ahead of time. You can see, and this is a southbound, our first phase. You can see we have 6 girder lines in. The 7th girder line is down there on Central Ave, getting ready to get flipped upright and then flown into place. Because of the splice connections, it was imperative that we get span 1 installed and framed up with diaphragms, and now your line and grade is locked in. Everything else had to go in sequentially, just because of the amount of slack from the bolts and the holes. There wasn't a lot of slack, and considering the magnitude of the connections, we had to do it in that way because it would have been too much of an effort to set, that adjacent span or that other span, opposite span, span 3, and then fly in that center section. If there was any movement, we would have to go back and pick it up. So the order of erection was your initial span, you'd fly in and rack a couple of bolts to get your connection, and then you could fly in that 3rd span, which you'll see in this view right here. You can see your initial span on the far side, and then 2 cranes hooked up in tandem. The heaviest pick were your abutment to pier spans that had the cantilever on there. They were right at 35,000 pounds with rigging. And then your center section was a little lighter, a little longer, but a shorter cross section. And it was right at 20-something thousand pounds. Like John mentioned, there were a ton of bolts. I did John a favor, and I didn't tell anybody that he was a designer when he was out there. So he could avoid a lot of dirty looks, but there were, I want to say, 220 bolted connections per splice. There were 30-something splice connections, which came out to right under 7,000 bolted connections at the splice locations. When you add up all the steel diaphragms, there's over 7,000 connections. So this takes some time. They're all torqued in the 650 foot-pound range. There's definitely been a lot of effort on there. One thing I did want to add about the steel management is these plate girders came from a vendor, from a developer in Oklahoma City. And myself and the project engineer and one of our structure superintendents have flown out there in October, about a month before they shipped, and they had most of them mocked up. We just, another secondary quality assurance, how are we going to ship these out? Here's our sequence. And everything was set. And literally the day after the first 6 or 7 girder lines came out, the Panhandle had a huge freeze and it knocked a lot of their power out. And their logistics officer lost all communication with all of the transport drivers, which they had hired locally. So we were literally using every means of communication with the manufacturer to track down these individual truck drivers who had to pick a different route to get here to Phoenix, and they got out of whack. So Zach spent a tireless week of organizing the drivers that come in at certain times and then getting them staged. The hardware came on rail, the girders came on truck, so everything was scattered between here and Oklahoma City. So it was a pretty long week getting them organized, but once I got here, we got them organized and it went up. We were able to hang the first span during the week at night, and then over the course of a long weekend, we got the majority of span 2 and 3 in, and then a couple of nights we hung the remaining girder line. So it went pretty good. Uh, challenges is normal. There's always something. Once we got a deck on it, we decked it, and then here was our first deck placement. This is southbound. Start early, finish early. No issues with the deck placement. Came out really good. Right, smooth. Current status. We just concluded northbound erection about a week and a half ago. We're still, I think we blocked in our last diaphragm this week. And we're in decking mode right now. We got caps hung. That deck placement is scheduled for the end of this month. So we're tracking well from a schedule perspective. As John mentioned, there's about 200 foot of embassy wall on all three corners. These come off the cast in place abutments. This allows us to make the rough grade with the structural fill and then finish base for PCCP. Here you can see our sister company McNeil put down a bunch of mud, approaching our anchor and approach for the bridge work, and drainage tying into the system. Got a new watershed area. We're tying it. It's got a new drainage feature up on main line that we chase down to an existing system down there on the frontage road. And that's generally the sequence of events and kind of where we're at with construction. You know what? John flashed a slide of his team. It takes a lot of people to get these off the ground. One from from development, even through procurement and construction. But it's tough working condition just given the area, ingress egress, and the secret sauce for us is definitely all the guys and girls, men and women, putting work in place, whether they're on equipment or swinging hammers. And I'm proud to say that all these guys are all superstars, and Zach Johnson's been a hell of an engineer, pushing the schedule every day. We got Tracy McKee building the bridge work. He's responsible for a lot of bridges here in the Southwest region. We got Marty Leclerc as the general civil superintendent, and Sippy Cardenas placing all of the concrete for the project. So our secret sauce is definitely our people, and all that good looking work you see out there is attributed to these guys right here. I'm going to hand this back off to Jimmy, and then I think we'll take questions. Jimmy?
All right, yeah, I've got it. Okay, I think you got my webcam going too. All right, there I am. Okay, so I'm just gonna talk about some of the successes and just wrap it up here real quick. So part of the team successes, I think one of the biggest things is adapting to the change that's gone on through the life of this project. I think the big one, as the subtitle of this presentation would you find there, is that construction in the year COVID. So I just went back real quick to check out the timeline of events on this project and wrote them down. So March 11th, 2020. Many of you probably want to forget that date. That was the date that Governor Ducey actually declared a state of emergency due to COVID. At that point, we pretty much told everyone, all right, if you can work from home, go work from home. If you can't, just stay away from me and wear a mask. So at that point in time, we hadn't even had the partnering and pre-con yet. Didn't know Reese from John. Well, I knew John, but didn't know Reese from anyone else in the project. Hadn't seen him yet. We didn't have that opportunity to build a working relationship with the team members. So we go into partnering on April 3rd, and at that point in time, we had just really gotten into the groove with the webcams and doing all the stuff through teleconference. So our first meeting for this project and our partnering meeting was done online. So it was a bit of a challenge to start with. I mean, you had a lot of players in the room, try to kind of feel out how a partnering meeting, which is supposed to be the groundwork for your working relationship, we actually meet and greet and eat with people, didn't have that opportunity at this one. So that was a bit of a challenge to start out with, but I would say that the team that we had, or the team we have, very like-minded in the sense of, we want to make sure that we're maintaining, focus on the project and seeing the larger picture. And I think that's really played a key role in this whole thing. I mean, even halfway through the, project, we were still meeting online just due to the fact that we had all the COVID restrictions. Didn't want to put anyone at risk. The last thing we wanted to do is someone in our office get sick and then get everyone else sick in our office and then get everyone on the contractor sick. And now you have a project which, perhaps needlessly had to be delayed or put on hold because a bunch of people, were out with COVID. Thankfully, I mean, we did have a few COVID cases on the project, on both sides. Thankfully, everyone's recovered, at least to my knowledge. But all good on that front. We've been able to maintain the project schedule and have had very little impact with that. Another thing with adaptability to change is, when something comes up in a project, especially with COVID, it made it a little bit of an issue. Like, okay, we have a situation on site, and I'll kind of highlight one in particular here, Reese, if you don't mind. The girder strands that were discussed earlier by John. So these were girder strands that were post-installed. So the markings on there, that's me trying to figure out at 5:30 Saturday morning, what the heck are we talking about on this phone call? So what happened was early during the phase 1 bridge demo, I get a phone call. I think it was a phone call from either Reese or my lead inspector saying that, hey, we got some cables here that kind of in tension, and we're not sure if we can get rid of those or not. So trying to figure out 5:30 with a bridge demo that's supposed to be completed by 5 o'clock Monday morning. So we had a little bit of time, but I don't really want to leave half a bridge up through the weekend or compromise the remaining half after the weekend. So talk with Reese a little bit. We went back and forth. We talked about, okay, these girder strands here, and then this, C channel that's located underneath that's attached to these girders here. What are we supposed to do with this? Because these strands are in tension. What do we need to do to make sure that, is it a structural member? What is it? So got on the phone with Jackie Noblet from Stanley, who was the Stanley project manager on this job. And I said, Jackie, I got a problem. I don't have John's phone number. What's going on? So she was on the ball. She called John, got a phone call from John probably about half an hour later or so after he woke up. I'm like, what the heck is going on? They got on a conference call, both he and I and Reese. One of the nice things that come to find out, hey, you can do conference calls on iPhone. Didn't know about that, but now I do. So really attacked this issue head on. Again, kind of a spur of the moment thing. Didn't really know what was going on. We were able to draw up an issue, and John was able to actually make it on site. And he was able to draw up a detail. And so what we ended up doing is attaching this these C channels here to the bottom of this center girder, which was the one that John was talking about that was done with the center infill, which we were able to make sure that the structural integrity of the remaining half of the bridge was not going to be compromised at all with us demoing the second half of the bridge. And then a little bit later, I got a phone call from Dan Shiozaka about the history of the bridge, and he's wealth of knowledge, great information. He's sitting there talking to me, and I'm sitting here, I don't know if this meme even, fits a situation, but I imagine this being Dan and this being me, he's just going on and on about all the stuff that's going into the design of the bridge and the history of the bridge. I'm like, holy cow, I didn't know any of this. This is incredible. And just talking about the design and the reasoning for, get rid of this meme because now that's recorded for ever online somewhere. But he was talking about the design considerations with the original design and why those PT strands were put in. So it was a good lesson learned with that respect. It's like, okay, this is something that going forward, make sure that all the structural members are, not to say they weren't accounted for, but and it actually turned out that some of those PT strands hadn't been tensioned anyway, and we're probably fine. But spur of the moment kind of thing, we've got a bridge. We want to keep the other half up after the weekend. We don't want anything to, have any issues with that going forward. So made a call. Ended up being, I believe it was the right one. My boss said it was the right one, so I guess that's all that matters, right? And we were able to move on with the project, and the bridge demo continued as originally planned. And one of the other things is kind of rolls into that as maintaining project focus, but also seeing the larger picture. So wanting to make sure that, we had the best interest of the project in mind. That's one instance. That we're doing some other things, adding a little bit of additional work onto the project to looking at the long-term maintenance of this corridor and of our infrastructure, keeping that in mind. But also seeing the larger picture. So one of the other things that may not have been mentioned was the fact that if you drive down Central Avenue, you'll see Valley Metro Light Rail construction going on right outside of our project limits. So with the team that we've got, being able to adapt to change, getting all the players in the room, we've been able to meet with Valley Metro on a number of occasions and allow them to work concurrently or sometimes non-concurrently in our project area to facilitate their project construction and, to keep on their project schedule. And having the team that we do have, I want to, really kind of push that, having Stanley or, John and Jackie on board from the Stanley, and having Reese and Zach on board. And, somehow I've gotten things done on my side. Having that team together, keeping the large picture in mind, but keeping focus on the project and not letting that get lost, but looking at the, I guess, quote unquote, meta narrative of this whole thing of, okay, yeah, we can not work with Valley Metro, whatever, but at the end of the day, we also want to see them done and successful and get their light rail in and get their project done with. So if we can do anything to facilitate that change or facilitate that construction, then, why wouldn't we? So being a team, quote unquote, team player in that sense, and really kind of keeping a, big view on things is really something that, I think this team has really done a good job of keeping in mind. And then also this relaxed atmosphere, not getting too uptight about things, not letting, I think one of the big things is being able to joke at some of these meetings. I mean, obviously, if you've been watching this for more than 2 minutes and listening to me, you'll see that I'm not all that serious, which may or may not be a good thing. But I'd like to think that some of that relaxed atmosphere has kind of, quieted things down on the project. And that's on all fronts with everyone on this job, especially with COVID and everything that was going on. The last thing we need is a highly contentious, team of players or stakeholders in this project. And I think being how would you say, well, if I got a project that doesn't have the right players, then what am I supposed to do? Well, I don't know. I guess just be the right person. But then now we start getting into metaphysics and what does being the right person actually mean? And I think that's beyond the scope of this presentation. So we'll move on from that. But I will say, I think the teamwork and the team mentality that we have on this project is one of the big keys to our success. Reese, John, kind of want to let you jump in here too, if you guys want to add anything to that.
I'd echo those comments though too. I think there's been a series of challenges from a technical perspective and a cost perspective, and we've all been able to maintain open lines of communication. That loaded PT rod, as we started the demo, they started popping, and you could tell there was a bunch of energy in there. And to be able to call Jimmy at 0:30, and then John show up soon after, and we come up with a detail on the hood of my pickup, and in 3 or 4 hours we have a solution, and we really didn't have to stop production. And we never jeopardized not opening. That was like the first big challenge that we're able to tackle as a team. And from that point, we kind of were on a group text thread, and we could share progress of how we were doing and small talk amongst the team. So that definitely paved the way. And as Jimmy said, we do have a relaxed relationship between meeting the quality and requirements, but having fun with it too. COVID was a son of a bitch. It's still a son of a bitch. And I would say as engineers and managers, we're tasked with managing resources. And our most precious resource are the people that put work in place. And we're tasked with bringing a project home on time and on budget and keeping safety at the highest priority. COVID added a significant wrinkle into what we're tasked with, and it was a different dimension. The personnel that we have in the field put work in place don't have the luxury of working from home. They have to show up, punch in and punch out every day, but we understand and we're challenged with the same things they are, with young children at home, and now a school is closed down, and now one parent's got a homeschooler. So we have to look at our resources and maintain progress on the schedule. And we've been able to deal with that through shifting resources and accommodating all the challenges our team members at the project level have had. So I'm really proud of our entire team have been able to come out of that and still, and like Jimmy said, it's been a minor impact. I mean, it's kind of been annoying, but in terms of the project impact, it hasn't been significant. Hey, we're delayed 60, 90, 120 days. No, we're going to finish on time, and hats off. And a lot of that has to do with being able to work quickly with John and Jimmy and the rest of our teams on challenges. So I've appreciated it. It's been a great project. We're on the downhill stretch now, but it's been a pleasure to work with everybody, and everybody's done really good.
Yeah, I have to agree with that also. Working with Reese and Jimmy has been really good. Everybody on the project wants a successful project. Police is doing an excellent job. From every time I've gone out there, the work has been top notch. And if they do run across something, they don't just stop everything and say, well, what do we do, Mr. Engineer? That they're right there taking an active part in coming up with solutions and keeping the project moving forward. So it's been a real good project.
I would wholeheartedly agree with all that's been said there. Just to keep pace with everyone, decided to put together my own slide. This Trent Kelso guy, he's okay. Oh, hey Trent, you're on the call. Never mind. He's a great guy. Great, absolutely great.
Sorry,
How
there
you
you
doing,
go,
Trent?
Jimmy.
There you go. So then also my staff that have working in the office, John Thompson's acts as my project supervisor, kind of been the right-hand man on this job, done a great job on this project. My office staff internally, I got Roxanne Lopez and Aaron Morgan. My material coordinator, Gabe Indiola, has done a great job as well. And then we've got our field guys on site. I got Jaime Laura and Lou Powell, who work for my office. Bunch of great guys, have done a great job on this project, working with police and then working with us. I've also got let's see, 5 consultants on the job who worked at one point or the other on a project. Tace Herman with Civil Solutions, Tenry Smith and Chet Doring with HDR, Russell Belcher with Consor, as well as Brandon Dillenbeck with Consor. So they're the ones, at least from ADOT's side, who have really kept this job going, done a great job working with police, working with the design that Stanley's given us, and putting up with me, I suppose. And this doesn't account, obviously, for everyone that was involved in development, whether it was Sarah Howard or Adam Carrion, or my boss that was working on this project with me, Dylan Carty. A lot of people touched this project. A lot of people have had their hands in and made it to where we're at on this project. And I think that all that work that they put into it is a testament to, or our project success is a testament to what the impact that they have. So let's see here. Mercifully, that's it. Sorry everyone for my bit. Reese and John were great, but that's all I've got. So let me stop sharing here. And I'll hand it back off to Joe.
Yeah, we have a few questions. First off, I want to say thank you to Jimmy, John, and Reese. That was a great presentation. And all of our attendees, thank you for attending. Certainly understand if people have to go, but we do have a few questions that we're going to ask, and if the panel can stick around and answer them, that'd be great. First one is, you mentioned a lot of utilities. Were there any utility relocations required?
There was one significant one that serviced the intersection on the southern side. I think the as-built showed the power feed coming on top of the west abutment footing. What we did find is that conduit was cast inside the abutment. So we never found it, and we potholed it. We found it outside of the abutment. And interestingly enough, when you look at the as-built, those old sim abutments have a counterfort wall in the back for rigidity. So it wasn't as easy as potholing right next to the abutment when we first jumped on it. So we knew it was on the ramp side. And as we started the demo, and as we started the pothole and soft dig around that south side, we kind of found, once we removed that little retaining wall, we found the conduit coming out of the button stem. So We swept it across the front of the pier line for the future improvement to avoid it in the future. But that was probably the biggest one. We found a couple of old conduits, but we were kind of wincing at the idea of, having to open dig a lot of this stuff and what are we going to find, what skeletons and other things that we might find at Central Ave and Metro Phoenix. But surprisingly, knock on wood, if you guys heard that, nothing's really stopped us. It's been, significant.
Oh, well, that's great. Was there any additional right-of-way required?
Jimmy, do you want to answer that one, or maybe
No.
we'll get
Oh,
Jackie Noblet involved?
yeah, maybe Jackie, but yeah, to my recollection, there was no right of way needed to be taken on this project. Everything was done within ADOT right of way.
Right. In the early stages of the DCR, when we were looking at building a full width spine cross section, there was a substantial amount of right of way that was required. But when we backed off the cross section to the auxiliary lane cross section, all of the new right of way went away.
Great. And then I guess kind of along with that, since there's no right of way required, how did well, I guess project's not done yet, but budget-wise, is everything falling within budget?
Yes, sir, it is.
Yeah, from a contracting perspective too, we're on track. No complaint.
Somebody wants to know, were there any impacts to the businesses in the area during construction that you had to make, account for?
So that's a little bit hard to quantify, just due to the fact that one, we had Valley Metro Light Rail building right side of our project area, and two, we had COVID. So with regard to ours, I would say there really hasn't been too much disruption of business, just due to the fact that we haven't had to take any additional right of way. Central Avenue through that area is a little bit lighter in terms of traffic in that area. 7th Avenue and 7th Street are the main corridors. But with COVID, really that kind of changed everything up with regard to the impact of businesses as well as traffic in the area. I mean, I'm sure as you guys may have seen on some of those slides, we reduced traffic to 2 lanes in each direction. And we were wondering, okay, how, and we had pushed everyone to one side of the freeway while we, did the phased bridge construction. How's that going to work out? Well, before the project even starts, all of a sudden you have COVID. So one of the byproducts of that, I guess, I don't want to say beneficial, but one of the nicer things that we kind of saw from that is just a reduced level of traffic out in the freeway. So we didn't have a lot of the large backups that we were expecting to see. We're starting to get more people on the freeways now, just because with everything opening back up. So we're starting to see some of the backups, but it actually really hasn't been all as bad as we had initially thought.
Great. And the last question is, were there any environmental issues on the project?
From a contracting perspective, no.
And I would say from an ADOT, construction management's perspective, no, not really. I don't know if Jackie or John want to highlight anything that they had to contend with in the development portion, but from the construction side, we haven't had any environmental issues really.
I can't recall if the existing bridge girders had any lead paint or there was any asbestos in the concrete, but those would be the only environmental issues that I would be aware of.
You're right. Those girders were hot, and even when we had to install those gussets, there was strain that C channel going across. We had some abatement to weld back there, but during the demo, we abated prior to demo and then pulled the girders up there and abated where we torched them in half to transport them to recycler. So other than the lead on the existing girders, I don't believe there's anything else.
All right, great. Well, no more questions now. And I think if anyone does have questions, they can certainly get a hold of Jimmy, John, or Reese, or get through any of the Phoenix board, and we can pass those along to them. And again, I'd like to really thank Jimmy, John, and Reese for a great presentation. Looks like a wonderful project. And of course, I, for one, am really happy when projects get done. This makes driving so much easier. So thanks, everyone. And no meeting next month. We'll hope to see everyone in August. Thank you.
Thank you.
Thank you.